Kia ora, Year 10. This video is for Ollie and it's going to go through the quadratic algebra work that we've done. So I'm going to look at 3 skills in this video and I'm going to go much faster than when I first taught it in class. Right? So the first thing we're going to do here is do some expanding because it helps us remember what factorizing is all about. So here's the factorizing section. And lastly, I'm going to look at how to solve quadratic equations. But if you've understood the point of factorizing, then the solving equations part is really straightforward. Okay, so let's go back up to expanding. Now I'm going to do one of these slowly and then I'm going to move on to what I've called Lachlan's method in class, which is moving to using just algebra. But the first one I'm going to do here is one where we look at what it means to expand. And we're going to think about this paddock that has got 2 dimensions. So the length of the paddock is x plus 7 and the width of the paddock is x plus 2. And to find this times this, it's the same as thinking about the area of a paddock as the length plus the width. So when you look at this, I could split this up into 4 simpler problems that I already know how to do. So if we grab the ruler, we can divide this up into 4 little rectangles with some simple algebraic stuff. So this paddock here has got an area of x times x, length x and width x, so its area is x squared. This one here has got a length of 7 and a width of x. This one down here has got a length of x and a width of 2, so 2 times x is the area and it's 2x. And then lastly, this one here has got an area of 2 times 7, which is 14. So the area of the whole thing adds up to x squared plus 7x plus 2x plus 14. Now, because we're at the end of this topic, this pattern will be pretty familiar. We almost always are going to get 2 terms that have got something x. Sometimes there'll be a positive and a negative, sometimes there'll be 2 positives, and sometimes there'll be 2 negatives, whichever one I didn't already say. In this case, this is what we get when we expand. But we don't want to have to draw the rectangles all the time because that would get really slow. But that's the idea underlying what we're doing. So the next step that we moved to was to write out, using algebraic statements, or mathematical statements, what we're really saying. So here, when we've got x minus 7 times x minus 2, we can think of that as x lots of this, x minus 2, take away 7 lots of this. And then we can expand as we learnt in year 9. So we've got x squared minus 2x minus 7x plus 14. So that's kind of step 2 when we learn how to do these. We get x squared minus 9x plus 14. But once we get better at that, we don't always have to write all of this out, right? So we want to be able to go a little bit faster than that. So the other way to do this is just to think about that method, but not to write it all out. And either of these approaches are fine, right? So here we know that we have to multiply the x times all of this. So that gives me x squared minus 2x. And we know that we have to multiply this by all of this, but we don't write it all out. So we get minus 7x, and then we have negative 7 times negative 2, which gives me the plus 14. So it's just a little bit more concise. And that's the minimum working that I'd like to see in year 10 for when we expand a quadratic, right? Because it's pretty clear what you're doing. So let's go on to these next couple and we'll look at the patterns. So we could write it out like this, but we don't have to do that. We can go straight to thinking about this. So it's x squared minus 2x plus 7x minus 14. Now here we've got to watch how we combine those like terms. We're going to get x squared plus 5x minus 14. For the next one, you'll see that what we've got going on here is that in each of these 4 examples, I've made the numbers 7 and 2, but I've changed the sign pattern, right? So here we've got a plus and a plus. Here we've got a minus and a minus. Here we've got one of each. here we've got one of each, but the other way around. Right? So for this one here, we're going to have equals x times x plus 2 minus 7 times x plus 2. You don't have to have that line of working, but it's always a good one to put in especially if you're doing a harder problem. Right? So we've got x squared plus 2x minus 7x minus 14, which gives me x squared minus 5x minus 14. Okay, so now let's look at how, that's all I'm going to do in this video on expanding. Let's look at how we could go backwards. So suppose that you were given x squared minus 5x minus 14, and you had to think about how you could get it back into factorized form. So we're looking for something times something. So the first bit is the easiest bit. We need to have something that's going to give me that x squared. So it's going to be x times x. We know that this negative 14 is coming from this and this. So what I'm looking for here are two numbers that are going to multiply to give me negative 14. And this middle term, the minus 5x, has to come from the two like terms. So this one and this one. So what has to happen to get the minus 5? Well, I need to have two numbers that when we add them up will give me negative 5. So we want this plus this is equal to negative 5. Now I've started not with the easiest kind here, and I'm doing that on purpose because this is a revision video. If you're finding this really hard, I'm about to go back to the very first kind of factorizing type. But I just want to show how this flows from that last example of expanding, right? So here, I'm looking at that negative 14, and I'm thinking about two numbers that times to give me just 14. And it's going to be some combo of 2 and 7. But down here, I want to have it, so I'm either going to have 2 and negative 7, or I'm going to have negative 7, or negative 2 and 7. But I want to end up with a minus 5x. So that means that the pair that I want is 2 and negative 7. Right, and when we put that back in, we can see if it works. So we never need to get a factorizing question wrong because we can always check it back. So we've got x plus 2 times x minus 7. So let's see if that works. Expanding it back, well, we get x squared minus 7x plus 2x minus 14. So it does work, right? Because this gives me the negative 5x. Okay, I'm 8 minutes in and I haven't even got to lots of the factorizing examples. So let's get going on those now. So here are a bunch. And they're not all going to be the same exactly as the ones we've just done. So we're going to think about our brackets. We need x times x here. Now, the first thing we look at is the sign pattern. We want to end up with a plus 14. That's coming from this number times this number. So that could either be a positive number times a positive number, or it could be a negative times a negative. So now I look here at the plus 9x, and that tells me that it's got to be coming from two positive numbers. So I want two numbers that multiply to 14 and two numbers that add to give me 9. So this is the easiest pattern type. It's going to be 2 and 7. Moving to the next one, I've just changed it a tiny bit. We've got x squared minus 9x plus 14. So we'll have x times x, two numbers that times to give me 14, but add to give me negative 9. So here I need to have a negative times a negative. So I'm thinking about negative 7 and negative 2. So we put the signs down first and then think about the numbers. So my thought process here is still two numbers that are timesing to give me 14. So it'll be minus 2 and minus 7. Now in the next one is a mistake. This one can't be done. It should say minus here, and this one should say minus here. And that's what happens when you try and make videos in a big hurry after school. So let's get rid of this mess up here so we've got a bit more space. This time, I know that I'm going to start with 2 brackets. I know that because it's x squared and I've got 3 terms. Okay, so I'm going to have x times x here and then something, something. I want to end up with a negative 14. So it's going to be something times something equals negative 14. I need 1 positive and 1 negative. So what I'm thinking about this time is the gap between the 2 numbers. If you think about just ordinary old 14 and the factors, what we're looking for is the factors of 14 that have got a gap of 5. Here's why. If I put in here x plus 2 and x minus 7, when we expand back, we're going to get our x squared, take away 7x, plus 2x minus 14, which is what we want. Right now that's happening because if you just think about the 7 and the 2, there's a gap of 5 between those 2 numbers. So when you take 7 away and then add 2, you get back to what we want, which is negative 5. And we're going to have minus 7 because we want to end up with minus 5x. In the next example, we get x times x. We're going to end up with a minus 14. So we've got to have a plus and a minus, right? A positive number times a negative number. 2 numbers that multiply to give me negative 14, but add up to give me 5. I'm still thinking about the gap between the numbers, but this time I'm going to put the big number here. So we're going to have plus 7x, take away 2x. Okay, so that's a little bit of factorizing. Ollie, that should be enough that you can go and try the Dr. Frost questions. I think this hopefully has helped you remember it a wee bit. Let's quickly look at what it means to solve, because I've got 2 minutes left. So when we've got quadratics and they're in factorized form, it's really, really easy to solve. What we mean by solve is to find the value of x that is going to make this equation true, to make it a true statement. So let's remember that if I have 0 times anything, that will equal 0. So when I've got a quadratic, there are 2 ways, usually, that I can get a true statement. If this first factor is equal to 0, then I'm going to have 0 times something. And we know that that will equal 0. Similarly, if the second factor equals 0, then I'm going to have blah, blah, blah times 0, and that will equal 0. So there are 2 values of x that would make this statement true. And if we write it out like this, when we get to do more complicated problems, it gets really easy to follow the same logic. So either x plus 7 is equal to 0, x is equal to negative 7, or x is equal to negative 2. We don't have to write all of this out as long as we understand the logic. So for this one here, we can see we've got something times something equals 0. So either x equals 7 or x equals 2. For this one here, x equals negative 7 to make that one 0, or x equals 2. There are 2 solutions. And for this last one, x is equal to 7 or x equals negative 2. So there you go. There's a really quick review of the quadratic work that we've done. Now can you go and have a go at the Dr. Frost and email me if you're still having trouble. Thanks very much for watching.